But how do they form?
One argument is that they come from airplanes, but not from toilet drainage because this would mean contaminants and cleaners would be found in these large ice stones. However, ice might still form and break off of airplanes while in flight. And since it could take as much as 3 minutes for such a piece of ice to reach the ground, such meteors might seem to come from out of the blue because the jet plane is long gone by then. A growing number of meteorologists, however, do not buy into the airplane scenario. They speculate that cooling and water vapor conditions within the tropopause that are still little understood may explain the formation of meteors. Regions are the central plains in the United States and Canada, Central Europe, and parts of the Ukraine, southern China, Argentina, and parts of Central and South Africa and southeastern Australia.
What is the difference between a National Weather Service advisory, statement, watch, and warning?
The National Weather Service will issue a statement as a first alert of a major change in the weather. An advisory is issued when weather conditions are not life-threatening, but individuals need to be alert to weather conditions. A weather watch is issued when conditions are more favorable than usual for dangerous weather conditions, e.g. tornadoes and violent thunderstorms. A watch is a recommendation for planning, preparation, and increased awareness, i.e., to be alert for changing weather. Listen for further information, and think about what to do if the danger materializes. A warning is issued when a particular weather hazard is either imminent or has been reported. A warning indicates the need to take action to protect life and property. The type of hazard is reflected in the type of warning, e.g., tornado warning, blizzard warning.
Where can I get an education in meteorology?
There are numerous colleges and universities throughout the United States and the world where you can earn a degree in meteorology. The American Meteorological Society publishes information on this in its curricula in the atmospheric, oceanic, hydrological, and related sciences, which can be accessed online at http://www.amitsoc.org. The U.S. military also provides training to interested recruits. Online and correspondence courses may be found, too, but these should be viewed more for informational purposes and not for a formal education. Unless the online courses are provided by a degree-conferring, accredited university.
Does the Earth's tilt ever change?
Yes. Our planet actually wobbles a bit, like a spinning top running out of steam. Currently, the axial tilt of our planet is about 23.5 degrees, which is somewhere in the middle of its total capable range of 22.1 to 24.5 degrees. The change in tilt occurs over a period of about 41,000 years.
When does frost form?
A frost is a crystalline deposit of small thin ice crystals formed on objects that are at freezing or below freezing temperatures. This phenomenon occurs when atmospheric water vapor condenses directly into ice without first becoming a liquid. This process is called sublimation. Usually frost appears on clear, calm nights, especially during early autumn when the air above the earth is quite moist. Permafrost is ground permanently frozen that never thaws out completely.
What is Gay-Lussac's law and why is it important in meteorology?
Joseph Louis Gay-Lussac, 1778 to 1850, was a French physicist and chemist best known for two laws of physics about gases. One of these laws states that, in chemical reactions, gases combine in simple ratios according to volume. For example, it takes two carbon monoxide molecules, Co, to combine with one oxygen molecule, O2, to create carbon dioxide, CO2. This became known as Gay-Lussac's law and is important for understanding chemical reactions of gases within our atmosphere. Gay-Lussac also published a law about gas expansion by volume occurring linearly as a function of temperature. Sometimes credited as another of Gay-Lussac's laws, it is more correctly called Charles's law. And Gay-Lussac was one of those who gave credit where it was due. It was discovered by another French physicist, Jacques-Alexandre César Charles, 1746 to 1823, who was also a mathematician. Charles found that gases such as oxygen and nitrogen increased their volume by 1/273 for every 1.8 degrees Fahrenheit 1 degree Celsius increase in temperature. From this, he extrapolated the possibility that, at absolute zero, -273 degrees Celsius, or -459.4 degrees Fahrenheit, the volume of a gas would also be zero. Both scientists were also balloonists, which was handy, given their interest in the atmosphere.
What other countries also have weather satellites in orbit?
Currently, the following countries have weather satellite programs: Japan, Russia, China, India, South Korea, and Europe, European Space Agency. Japan launched its geosynchronous meteorological satellite Himawari in 1995, but in 2003 it malfunctioned. And so NOAA permitted the Japan Meteorological Agency use of the older GOES-9 satellite. The European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, operates what is now the second generation of Meteosat satellites. Europe launched its first weather satellite in 1995. And this second generation came online in 2004 with Meteosat 8. This satellite scans the entire globe every 15 minutes. China launched the Fengyun in 1990, and there have been several successors since then. That same year, Russia launched GOMS, Geosynchronous Operational Meteorological Satellite. The Indian satellite, INSAT, made orbit in 1990. And was used for both weather observations and communications. It was followed by INSAT 2 through INSAT 4 series, before the Kalpana 1 was operational. In 2002, the Kalpana 1 satellite is India's first exclusively meteorological satellite. South Korea's first weather satellite is the Communication, Ocean and Meteorological Satellite, COMS, which was launched in 2005.
What will happen when Earth's magnetic field flips upside down?
Probably not much will happen to our daily lives when Earth's magnetic field undergoes a polarity reversal. Measurements over the years show that there has been about a 6% reduction in the strength of Earth's magnetic field in the past century. So some scientists think that a polarity reversal on Earth will likely happen sooner rather than later. Some non-scientific hypotheses have been put forth, suggesting that there will be an environmental catastrophe as a result. There is no scientific reason to believe, however, that such disasters will occur.
What is the Kyoto Protocol?
An international agreement initiated by the United Nations, the Kyoto Protocol is a document that aims to reduce global emissions worldwide in an effort to stem and eventually reverse global warming. Adopted on December 11, 1997, the agreement has been signed by representatives from 184 nations. A central aspect of the Kyoto Protocol is establishing scheduled reductions in emissions. Reducing greenhouse gases relative to 1990 levels by 5% over the course of the years 2008 through 2012. Countries participating in the agreement can earn emissions-reducing credits by either reducing pollutants produced in their own countries, or through a carbon market, which is a system of emissions trading. In other words, a country that wishes to allow more emissions within their borders can purchase emissions credits from countries with lower levels and still be in compliance with the treaty. Countries can also earn credits by sponsoring emissions-reducing programs in foreign nations or building clean factories and power plants in other countries.
Who should be credited with inventing weather radar?
No one person decided to use radar for weather forecasts. With the technology already in place, it was simply adapted to this purpose when experiments in Britain and the United States showed that radio waves bounced off clouds. Radar was first used to specifically obtain weather data in 1949. But it was not until the mid-1950s that a weather station using radar technology was established in the United States. This happened after the eastern seaboard was hit by two vicious hurricanes in 1954 and 1955. The U.S. Weather Bureau was then authorized by Congress to create a national weather radar grid. And so the Weather Surveillance Radar, WSR-57, was founded in 1957. WSR systems used vacuum tubes and other technologies that were becoming outdated by the late 1970s. Despite the fact that vacuum tubes were in short supply, and other parts had to be hand-machined in order to keep the weather system running, Congress did not approve replacing the system until the 1990s.
What is diamond dust?
Diamond dust, also known as ice prisms, are tiny ice crystals that can form in the air on extremely cold days if the air contains enough moisture. The effect can be quite beautiful, as sparkling, barely visible crystals appear in mid-air on sunny days, catching the sunlight and, indeed, appearing as if they are tiny diamond chips wafting in the breeze.
What are dust devils?
These columns of brown, dust-filled air, which can rise dozens of feet, are not as evil as the name suggests. They are caused by warm air rising on dry, clear days. Winds associated with dust devils can reach up to 60 miles. 96.5 kilometers per hour and cause some damage. There have been reports of dust devils as tall as 5,000 feet, 1,500 meters. They are generally not as destructive as tornadoes and usually die out pretty quickly, though some have been known to displace as much as 50 tons, 4,500 kilograms, of dust and light debris. One of the biggest dust devils ever recorded was seen in Bonneville Salt Flats in Utah. It was hundreds of feet tall, and it continued on its way for about 40 miles, 65 kilometers.
How much drinkable fresh water is there on Earth?
Only 2.59% of all the water on our planet is fresh water. However, much of that water is now polluted, and hydrologists and environmentalists estimate that only about 1% of the planet's total water supply is clean enough to drink.
What are some cloud-to-space forms of lightning that are not considered to be true lightning?
There are 4 types of electrical phenomena that have been observed that are not really lightning but still involve fascinating atmospheric displays. Called transient luminous events or TLEs, they are usually seen during storms. They are sometimes called cloud-to-space lightning, though they do not actually originate within clouds. The first scientific paper on these phenomena was published in 1886, but scientists were not very interested in the subject until more recently, as photographic images became increasingly available. 1. Sprites, often reddish lights appearing above thunderstorms for very brief periods of time. Sprites look kind of like jellyfish, they have a blob of light on top and numerous tendrils descending downward. Sprites can shoot 55 to 60 miles, about 90 to 95 kilometers, up into the atmosphere, reaching the ionosphere, and extend 100 miles, 161 kilometers, across. They are very difficult to see, and for that reason were not reliably recorded until the 1980s. 2. Blue jets, blue lightning that emerges from the tops of thunderstorm clouds at speeds of about 62 miles. 100 kilometers per hour. Meteorologists still do not fully understand what causes blue jets. 3. Elves, a short name for a very long-winded description. Elves are emissions of light and very low frequency. VLF, perturbations from electromagnetic pulse, EMP, sources. Appearing as giant rings that expand up to 200 miles, 320 kilometers, in diameter. Elves exist in the upper atmosphere at elevations of 55 to 60 miles, 90 to 95 kilometers. Even more short-lived than sprites, they last about 1/1000th of a second. 4. Tigers, first observed on January 20, 2003. This newest atmospheric light phenomenon has still not been adequately explained by scientists. Tiger stands for transient ionospheric glow emission in red, and were first observed with the use of an infrared video camera over the Indian Ocean by Elon Ramon, an Israeli astronaut aboard the Space Shuttle Columbia, which later exploded, killing the crew. The tigers that Ramon observed occurred as bright flashes when there was no thunderstorm activity nearby.
Does water always freeze at 32 degrees Fahrenheit, 0 degrees Celsius?
The standard that water freezes at 32 degrees Fahrenheit, or 0 degrees Celsius, is only true when the air pressure is exactly 1 atmosphere. And when the water is fresh water and not salt water or some other form of water with impurities in it. Salt water, depending on the percent of salinity, freezes at a lower temperature than fresh water. And when the air pressure is greater than 1 atmosphere, the melting point of fresh water is lowered. However, it takes a lot of pressure to make a difference. To lower the freezing point of water to 30 degrees Fahrenheit 1 degree Celsius, you must exert a pressure equal to 134 atmospheres. Because water droplets in clouds must condense around impurities such as dust. They do not necessarily freeze at 32 degrees Fahrenheit but can remain in a liquid state at temperatures as low as -40 degrees Fahrenheit -40 degrees Celsius. In other words, the water droplets cannot form ice until they begin to make contact with each other around a nucleus so they can form a crystal lattice. On the other hand, icebergs in the salty oceans are frozen at about the normal freezing point because icebergs are actually formed of fresh water. This happens because ice in the oceans is often formed slowly, allowing the ice crystals to force out impurities such as salt. On the other hand, ice flow sections of the Arctic ice sheet that break away each summer are composed of sea ice. Sea water begins to freeze at 28 degrees Fahrenheit -2 degrees Celsius when there is no surface turbulence. Another interesting property of ice on frozen lakes or in skating rinks is how friction makes ice skating possible. It was once believed that the pressure of an ice skate blade against the ice surface changed the state of the water from solid to liquid, thus creating a slippery surface on which to glide. More recently, it has been concluded that it is the friction of the blade against the ice that melts it and makes ice skating possible.
How did Charles Fabry discover that the ozone absorbs ultraviolet light?
Fabry, 1867 to 1945, invented the interferometer, a device measuring how light waves interfere with each other. With fellow French physicist Albert Parrot, 1863 to 1925. He used this Fabry-Parrot interferometer to measure the Doppler effect on light in the laboratory. Then, in a 1913 experiment, he used it to learn that UV radiation is absorbed by the ozone layer.
What is a tropical depression?
A tropical depression consists of a line of organized storms with wind speeds below 38 miles. 61 kilometers per hour. Tropical depressions have the potential to become tropical storms or hurricanes.
Does rain come in any other colors or is it always clear?
Yes, rain showers have occurred consisting of yellow or even reddish droplets. This usually happens when dust storms have seeded clouds heavily with nuclei rich in iron or other minerals. Yellow rain has also been observed as the result of pollens entering into clouds and then being absorbed into raindrops.
What role did Walter Maurice Elsasser play in discovering the magnetic field?
German-born American physicist Walter Maurice Elsasser, 1904 to 1991, was the scientist who discovered that The Earth's magnetic field is generated as a result of how the planet's hot core acts like a dynamo. He also brilliantly discovered that analysis of rock particles reveal clues about the orientation of the Earth's magnetic field over time, which in turn contributed to the science of plate tectonics and the history of Earth's climate.
Who first photographed a sprite?
In 1989, while experimenting with low-light video cameras for use in high-altitude rockets, University of Minnesota scientists Robert Nemzek, John Winkler, and Robert Franz accidentally captured images of sprites. This quickly piqued the interest of NASA scientists at the Marshall Space Flight Center in Huntsville, Alabama, who managed to record more examples of sprites. Later successes of taking pictures or video of sprites came from Walter Lyons, who filmed over 240 sprites on July 7, 1993, and Dave Asintman and Eugene Westcott of the University of Alaska, who used a NASA aircraft to film sprites that same month.
What is the SPF system?
The Sun Protection Factor, or SPF, rates sunscreens based on how much they shield your skin from ultraviolet radiation. Depending on your skin pigmentation and age, an SPF rating of somewhere between 30 and 50 is usually recommended for any lengthy amount of time in the sun. And children, especially, should use higher SPF-rated sunscreens. Sunscreen should be applied about a half hour before going outside. If you are unsure about what sunscreen to use, a good idea is to ask your physician or pharmacist.
What is the azimuth?
Used in navigation and in reporting the position of stars, planets, and other celestial bodies. The azimuth is the number of degrees between the direction of north, 0 degrees, and the direction in which the object is viewed from the perspective of the observer. In more mathematical terms, it is the angle between two vertical planes, one formed between the observer and the object observed, and the other formed by the observer and true north.
What is the effect of global warming and climate change on average temperatures?
By the year 2100, relative to 1990, world temperatures could rise from 2 to 11.5 degrees Fahrenheit. 1.1 to 6.4 degrees Celsius, and sea levels may rise about 3 to 5 feet, 1 or 2 meters.
What is a derecho?
Pronounced derecho, this is large, long-lived thunderstorm characterized by strong wind downbursts.
What is the difference between absolute humidity and relative humidity?
Absolute humidity is the actual amount of water that is mixed in with the air. It is measured in milligrams per liter. Relative humidity is expressed as a percentage and refers to the actual humidity divided by the maximum water vapor content possible at a given air temperature and pressure. For example, if a liter of air at 98 degrees Fahrenheit 37 degrees Celsius at 1 atmosphere pressure contains 44 grams 1.5 ounces of water vapor, and the actual water content is 11 grams, then the relative humidity would be 25%, 11/44 x 100 equals 25%.
When did radar finally catch on, and who gets the credit?
In 1935, over 3 decades after Hulsmeyer first proposed the idea, radar technology came into its own through the work of British scientist Robert Watson Watt, 1892 to 1973, along with H. E. Wimperis, 1876 to 1960, Henry Tizard, 1885 to 1959, and A. F. Wilkins, working for the British government. Watson Watt was given the assignment of investigating whether Germany's Adolf Hitler could carry out a threat of creating a weapon using radio waves. Watson Watt knew this was an impossibility, but he saw another potential use. Using shortwave radio transmitters from the British Broadcasting Corporation, he and his colleagues created the first practical radar technology. Radar was used to detect attacking German airplanes during World War II, and was credited with swaying the 1940 Battle of Britain in England's favor.
What type of pyranometer does the National Weather Service use?
Instead of the Campbell-Stokes recorder, the NWS uses a device called the Marvin Sunshine Recorder. A more elaborate device, it consists of one clear and one blackened bulb connected by a thin glass tube partly filled with mercury. As sunlight warms the blackened bulb more than the clear one, the mercury expands and shorts out an electrical contract that then operates a pen that marks a chronograph.
How much do meteorologists earn?
You should never pick a career solely based on its earning potential. Pick something you love, and then go from there. That being said, meteorologists make very good wages indeed. As of 2009, average salaries ranged from $70,000 to $108,000 annually. On the low end, the salary for a degree-holding meteorologist was about $53,000, at the upper end. A meteorologist in a specialized field with a PhD can easily make $125,000 a year.
Can the form of snowflake crystals be predicted?
Snowflake crystals come in several forms, including needle-shaped, plate-like, capped columns, and feathery dendrites. Temperature and humidity levels determine which type of shape is formed, so, yes. If these conditions are known, the type of snowflake formed could be predicted. In natural conditions, this would of course be impractical. But laboratory conditions could be established to form particular types of snow crystals, if desired.
What is a meteorologist?
People usually associate meteorologists with television station weathercasters. Most meteorologists, though, work behind the scenes. They can be found working for the National Weather Service, in laboratories, at weather research stations, or working for universities. Meteorologists need a good understanding of physics, chemistry, hydrology, and other disciplines to do their jobs well. The American Meteorological Society defines a meteorologist as someone who can research, observe, explain, and forecast the weather, who understands the principles behind weather phenomena, and who appreciates the effects that the weather has on Earth. Meteorologists obtain a bachelor's degree in science to do their jobs, and many of them have master's degrees or doctorates. There are also a variety of specialties in the field, such as hydrology and climatology. And many meteorologists study mathematics, computer engineering, electrical engineering, and more.
How does a lightning rod work?
Invented by Benjamin Franklin, 1706 to 1790, around 1750, the lightning rod is designed to provide lightning bolts with a safe path to ground the electricity so that it does not damage a building. Lightning rods have actually become a bit more important to have on a home or other building in recent years, because the metal pipes that used to be installed for indoor plumbing and that could serve as lightning rods are being replaced by non-conductive PVC pipes.
What is the difference between absolute and specific humidity?
Absolute humidity given in grams per cubic meter is the amount of water vapor in a cubic meter of air. Specific humidity is the amount of water vapor per gram of air.
Why was Hero of Alexandria an important figure in the history of meteorology?
We have hero, c. 10 to 70 CE, also spelled as heron. To thank for being the first to scientifically prove that air consists of matter. A genius who invented an early steam engine and showed you could harness wind's power with a windmill. Hero showed that air had volume, therefore, matter, with such creations as the pump and the syringe.
Among the hail belt, what are some notable record hail accumulations?
In 1968, a storm in Illinois dumped the equivalent of 82 million cubic feet. 2.32 million cubic meters, of ice over a 620,000-acre area. Then, in 1980, a hailstorm in Orient, Iowa, left hail drifts that were 6 feet, 1.8 meters, deep.
What chemicals are used in thermometers?
The two liquids that are typically used in a thermometer are mercury or alcohol. The alcohol in thermometers is dyed red to be easier to read, while mercury has a silver color. Both liquids work well in determining temperature, but alcohol thermometers are safer. Should a mercury thermometer break or leak, the liquid metal inside could evaporate and the fumes are toxic. Also, mercury tends to expand or contract more slowly than alcohol. Mercury, furthermore, can't measure temperatures below -38 degrees Fahrenheit. -38.9 degrees Celsius, because that is the point at which it turns into a solid. The disadvantage of alcohol, however, is that it tends to evaporate or polymerize over time.
What is Doppler radar?
Doppler radar measures frequency differences between signals bouncing off objects moving away from or toward it. By measuring the difference between the transmitted and received frequencies. Doppler radar calculates the speed of the air in which the rain, snow, ice crystals, and even insects are moving. It can then be used to predict speed and direction of wind and amount of precipitation associated with a storm.
How was the Fahrenheit scale developed?
The temperature scale still in use in the United States, while the rest of the world uses the metric system of Celsius. Is named after German engineer and physicist Gabriel Fahrenheit, 1686 to 1736. Fahrenheit developed his scale after visiting Danish astronomer Ole Christensen Romer. 1644 to 1710, in 1708. For his experiments, Romer was using an alcohol thermometer upon which he had marked a scale from 0 degrees, the lowest temperature he could achieve in his laboratory using a mixture of ice, water, and salt, to 60 degrees, the boiling point of water. This system actually mimics the basic idea behind the Celsius scale. While Fahrenheit left no records as to why he chose certain high and low points on his thermometers. There has been speculation on this matter. It is known that he used his own body temperature as the high point on his thermometer. But he marked this temperature as 96 degrees. Some believe he chose this number because it was easily divisible by 2s and 3s. For his 0-degree mark he used Romer's figure. Fahrenheit later determined that water normally froze at 32 degrees on his scale and boiled at 212 degrees.
What is lake effect snow?
Water evaporating off lakes can increase air humidity and encourage cloud formation and precipitation in areas near shorelines. As cold air moves over a water body such as a lake, it picks up moisture, then, when the clouds reach the shoreline, the air moves upwards in what is called the orographic effect. This, in turn, creates concentrated bands of precipitation that then release precipitation within relatively short distances of shorelines. Some record snowfalls have been documented as a result of the lake effect. For example, on January 17, 1959, 51 inches, 129.5 centimeters of snow fell on Bennett's Bridge, New York, over a 16-hour period. Buffalo, New York, is infamous for being buried in snow because of its proximity to Lake Erie. The winter of 1976 to 1977, for instance, saw the city experience 30-foot snow drifts. Storms with 70-mile, 113 km per hour winds and bitter temperatures led to the deaths of 29 people that season.
What is the worst avalanche disaster on record?
In 1970, an avalanche in Yungay, Peru, killed 20,000 people.
What are pollution hotspots?
Levels of pollution are not consistent throughout polluted areas such as industrialized cities. For example, car emissions along freeways raise air pollutants significantly in adjacent areas. And air quality inside tunnels and parking garages is considerably worse because of limited ventilation. Other potential hotspots include areas, whether urban or rural, that lie downwind of factories and power plants.
How fast does the seafloor spread?
Today, the rates of seafloor spreading vary from about 1 inch, 2.54 centimeters per year in the Mid-Atlantic Ridge area to about 6 inches, 15 centimeters, in the Mid-Pacific Ocean. Scientists believe seafloor spreading rates have varied over time. For example, during the Cretaceous period, between 146 to 65 million years ago, seafloor spreading was extremely rapid. Some researchers believe this quick movement of the lithospheric plates may have also contributed to the demise of the dinosaurs. As the continents changed places over time, so did the climate. In addition, more plate movements might have meant more volcanic activity, releasing dust, ash, and gases into the upper atmosphere and contributing to more climate variation. This change in climate and vegetation may have caused several species of dinosaurs to die out or become diseased, contributing to the dinosaurs' extinction.
What is seafloor spreading?
Seafloor spreading is one of the processes that helps move the lithospheric plates around the world. The process is slow but continuous, like a hot, bubbling stew on the stove. The even hotter asthenospheric mantle rises to the surface and spreads laterally, transporting oceans and continents as if they were on a slow conveyor belt. This area is usually called a mid-ocean ridge, such as the Mid-Atlantic Ridge system in the Atlantic Ocean. The newly created lithosphere eventually cools as it gets farther from the spreading center. This is why the oceanic lithosphere is youngest at the Mid-Ocean ridges and gets progressively older farther away. As it cools, it becomes more dense. Because of this, it rides lower in the underlying asthenosphere, which is why the oceans are deepest away from the spreading centers and more shallow at the mid-ocean ridges. After thousands to millions of years, the cooled area reaches another plate boundary, either subducting, colliding, or rubbing past another plate. If part of the plate subducts, it will eventually be heated and recycled back into the mantle, rising again in millions of years at another or the same spreading center.
What is irisation?
Sort of a diffused rainbow effect that can produce mother-of-pearl-like colors. Irisation occurs when thin clouds of water vapor, particularly altocumulus clouds, pass below the sun.
What was the Great Flood of 1993?
Heavy rainfall caused river flooding in 1993 that was so severe in Iowa that, when observed by NOAA sensors, the state looked like a sixth Great Lake. The Mississippi River was 7 miles wide at some points, and the Missouri River also spilled over its banks, causing nearly $20 billion in property losses, 48 deaths, and the evacuation of 85,000 people.
What is El Niño?
El Niño refers to the phenomenon that occurs when warming waters in the tropical Pacific build up around Christmas time. It is a fairly regular occurrence, every 2 to 7 years, but usually every 3 to 4 years. And with powerful ones every 10 to 15 years, and because it happens around Christmas. Spanish-speaking people called it El Niño after the Christ child. Meteorologists often refer to it as the ENSO, which is short for El Niño Southern Oscillation. The term Southern Oscillation was coined by Sir Gilbert Thomas Walker, 1868 to 1958. A British statistician and physicist who was studying the pattern of Indian monsoon seasons. The El Niño effect influences weather not only along the Pacific coasts of the Americas, but also worldwide. The consequences range from colder than normal temperatures in the central and eastern United States to strong storms in Africa, Australia, and the coast of California. Flooding in Europe, and declines in fish populations in South America. Climatologists increasingly believe that strong El Niños increase droughts in Africa and may be accelerating desertification there. A moderate El Niño effect was in action during the years 2006 through 2008.
What is Indian summer?
The term Indian summer dates back to at least 1778 and may relate to the way Native Americans availed themselves of the nice weather to increase their winter food supplies. It refers to a period of pleasant, dry, warm days from middle to late autumn that usually occur after the first killing frost.
Why are trees and other vegetation important to the weather and climate?
Cutting down trees, especially on the massive scale that is occurring today, has a definite effect on the weather in several ways. 1. Trees and other plant life absorb carbon dioxide and other pollutants that cause global warming. 2. Plants also absorb sunlight and areas covered by forest, thus reflecting less sunlight back into the atmosphere. 3. Trees near homes and commercial buildings help reduce electricity use, because they keep buildings cooler in the summer and serve as a barrier against cold winds in the winter.
Is there a classification system for snowflakes?
Humankind has an affinity for classifying just about anything, and that includes snowflakes. In 1951, the International Commission on Snow and Ice, yes, there was such a commission, created a system for putting a name on each type of snowflake. A daunting task when one considers that no two flakes are alike.
Who figured out that temperatures rise in the stratosphere?
Pioneering French meteorologist Léon-Philippe Tisserand de Bord, 1855–1913. Conducted an experiment using helium balloons and temperature sensors.
What is a nor'easter?
A nor'easter is a storm along the eastern coast of North America that affects the region. With northeasterly winds with speeds up to 75 miles, 121 kilometers, per hour or more. Such storms evolve when low-pressure systems accumulate humid air from the Atlantic Ocean or from the Gulf of Mexico, and combine it with cold dry air coming down from Canada in conjunction with a strong jet stream. The system rotates counterclockwise, bringing strong rainstorms in the south and, in winter, snow to the northeast. Nor'easters have wreaked havoc on the United States a number of times. For example, a February 1969 nor'easter dumped 70 inches, 178 centimeters of snow on Rumford, Maine, and 164 inches, 416.5 centimeters, on Pinkham Notch, New Hampshire. One of the worst nor'easters resulted in a superstorm in March 1993 that is still referred to as the storm of the century.
What changes in plant and bird behavior are indicating global warming?
People are noticing that spring is coming earlier, flowers bloom sooner, and summer has been lasting longer than in previous years, sometimes by a difference of 1 or more weeks. Bird migrations north and south have also changed, with bird watchers seeing species increasingly in northern climates where they have not before ventured. In North America, mammals such as possums and armadillos are also increasing their northern ranges. And a bit more worrisome insects such as fire ants and Africanized bees are also moving north.
What is syzygy?
Syzygy occurs when the moon and sun are aligned, an event that happens twice monthly. The effect on Earth is that the gravitational pull of these two space bodies is strengthened, increasing the elevation of high tides and decreasing low tides.
Where are aurorae seen?
Aurorae are most prominent at high altitudes near the North and South Poles. They can also be seen sometimes at lower latitudes on clear nights. Far from city lights, every once in a while, perhaps once every year or so, aurorae can be seen as far south as the lower 48 states of the United States. Displays of aurorae can be amazingly beautiful, varying in color from whitish-green to deep red and taking on forms like streamers, arcs, curtains, and shells.
Is there such a thing as a monochromatic rainbow?
There have, indeed, been rare reports of all red or all white rainbows.
What is the intertropical convergence zone?
The Intertropical Convergence Zone, ITCZ, is a band around our planet where the winds from the southern and northern hemispheres rub against each other. The resulting convergence causes air to rise and is an ideal place for tropical storms to form, generally near the equator. The ITCZ changes position depending on the effects of the sun and seasonal cycles. Usually, there is one ITCZ, but sometimes a double ITCZ can form. Land beneath the ITCZ receives much more rain, up to 200 days annually, than land areas outside the zone, and shifts in the zone can lead to wet or dry weather.
How is climate change affecting geyser activity?
Geyser activity is affected by rainfall levels and the frequency of earthquakes. In Yellowstone National Park, which is home to about half of the world's 1,000 known geysers, rainfall feeds into the Madison River, which supplies geysers in the park with their water reserves. Less rainfall in times of drought translates into less pressure in the geysers' reservoirs, and leads to fewer eruptions. In a recent study of rainfall and climate in Yellowstone, it was found that the amount of water flowing down the Madison River has decreased by about 15% from the years 1998 through 2006. This decrease in rainfall has been blamed on global warming, which has affected precipitation in the surrounding states of Wyoming, Montana, and Idaho. The study associated lower rainfalls with an increase in the intervals between eruptions of geysers. For example, Old Faithful used to erupt every 75 minutes, and in 2006 it was erupting every 91 minutes.
How do I find financial aid to study meteorology?
Other than contacting your university's meteorology department and its financial aid office. A good place to look for scholarships, fellowships, and internships is the American Meteorological Society. The National Council of Industrial Meteorologists also provides stipends to undergraduates. Finally, the U.S. Navy and Air Force both offer programs in meteorology for those who attend. The Reserve Officers Training Corps, ROTC, in college, and then go to officer training school. Your education is then paid for by the military.
What is the most dangerous month for avalanches?
More avalanches occur during the month of February in the United States than any other month. Colorado, Alaska, and Montana are the states where most avalanche-related deaths happen.
What was the Great Hurricane of 1938?
Possibly the worst storm to ever hit the American Northeast since the arrival of Europeans. The Great Hurricane of 1938 wreaked havoc throughout New England and down as far as Long Island. 600 people died as a result of the storm in what has also been called the Long Island Express.
What could happen if permafrost melts permanently because of global warming?
The problem with global warming is that, as the process continues, it tends to use a rather ironic term, snowball and accelerate. A big reason for this was recently discovered as a result of permafrost and peat bog surveys being conducted in places like Scandinavia and Alaska. Here, land that was once covered in permafrost is thawing out and becoming wetlands. This might sound very nice, except that, stored beneath this layer of permafrost, is a buildup of centuries of methane gas created by decaying peat and other plant matter. Once this thaws, the methane will all be released into the atmosphere, increasing levels of methane by as much as 50% by some estimates.
Is there much permafrost in the lower 48 U.S. states?
There is no permafrost in the lower 48 states. Those states such as North Dakota and Minnesota do often experience conditions where frost levels penetrate the ground to depths extended 30 or more inches, 76 centimeters.
What happened because of a dust storm in 1977?
One of the worst dust storms to hit the United States since the Dust Bowl occurred in February 1977, when fierce winds blew over plowed fields from Colorado to Texas, kicking up a huge dust cloud. The dust storm dumped 3 million tons, 2.7 metric tons, of soil onto the state of Oklahoma. The cloud continued through Mississippi and Alabama, dramatically raising particulate pollution, and continued across the country and far into the Atlantic Ocean.
Who first proposed the approach of numerical weather prediction?
Wilhelm Bjerknes, 1862–1951, a Norwegian physicist and meteorologist, was the author of the first formal studies on weather forecasting. He was also famous for his seminal 1921 book, On the Dynamics of the Circular Vortex with Applications to the atmosphere and to atmospheric vortex and wave motion, which proposed the fundamental ideas behind numerical weather prediction in 1904. The theory was picked up again in 1922 by English mathematician and meteorologist Lewis F. Richardson. 1881 to 1953, the mathematics behind Bjerknes's theory appealed to Richardson, but the calculations necessary to come up with the predictions in a time before the invention of the computer were formidable. Richardson estimated it would take a coordinated effort of about 26,000 people using calculators to figure out the math fast enough for the numerical method to work. Trying to do some preliminary calculations himself. Richardson's early attempts at weather predictions were far off the mark. His misunderstanding of some of Bjerknes's numerical methods led him to come up with estimates on air pressure that were far too high. Because of Richardson's failure, numerical weather prediction was abandoned until the 1940s.
What was the storm that wouldn't die?
In November 1992, Typhoon Gay lasted for days as it traveled thousands of miles across the Pacific Ocean, eventually making landfall in Alaska, British Columbia, and California. At its peak, the storm boasted winds of 200 miles, 322 kilometers, per hour. After making landfall in the United States, it continued across the Great Plains, then regained strength as it reached the East Coast. Here, it became a new storm on December 11 with winds of about 90 miles, 145 kilometers, per hour.
What was Hermann Flaun's contribution to climatology?
German meteorologist Hermann Flaun, 1912 to 1997, studied climate change on a macro scale. He conducted research on how large-scale changes in the Earth's climate, specifically how the entire atmosphere circulates, affect the environment. He was also one of the first to advance theories on how human beings affect the climate.
What happens to the Sun every 22 years?
The sunspot activity on the Sun is related to the magnetic field change the Sun goes through. Every 22 years, the Sun's magnetic field completely reverses. Magnetic north becomes magnetic south and vice versa. Other than having something to do with sunspot activity, astronomers do not believe that this flipping affects our weather in any way.
Do rainbows ever appear by moonlight?
Yes, if there are raindrops in the air, and the moon is full and low on the horizon. The result can be a nighttime rainbow or moonbow. Usually, such a rainbow does not have the vibrant hues of its daytime cousin, appearing in muted or whitish shades. A moonbow is a rare and stunning sight.
How hot can the human body get and still survive?
University-level research has included experiments that show that the human body can withstand a temperature of about 250 degrees Fahrenheit 121 degrees Celsius for up to 15 minutes. A more extreme case in which a professor conducted the research on himself showed that a healthy person could withstand 364 degrees Fahrenheit 184 degrees Celsius for 1 minute.
What are the most extreme barometer readings ever measured?
On December 29, 2004, a barometer reading of 32.25 inches of mercury was taken at Tonsant Sengal, Mongolia, a world record. At the other extreme, a reading of 25.63 inches was recorded on October 12, 1979, in the Philippines within the eye of Typhoon Tip.
What is a floodplain?
A floodplain is the area surrounding a river that, when unmodified by human structures, would normally be flooded during a river flood. A floodplain can be a few feet or many miles wide, depending on the river flow as well as the local terrain. Even though levees and flood walls can be built, with homes and businesses built just behind them, the floodplain does not vanish. If the structures break or are damaged, the water from a flood can fill a floodplain, just as it did before humans occupied it.